Okay, class, we're starting on section 2.1, sign numbers, which are also called integers. Section A, representing real-life situations. In this course, we have only dealt with numbers that are 0 or greater. Numbers greater than 0 are called positive numbers. However, there are many situations in life where we need numbers less than 0, such as below 0 temperatures, measuring below sea level, etc. So we need to use numbers that are less than 0 and are commonly called negative numbers. Sign numbers are known as integers. Okay, now we come down here to this graph. If you notice here, to the left of 0 we have our negative numbers, and to the right of the 0 we have our positive numbers. 0 is neither negative nor positive. Now, helpful hint. Now this looks like a subtraction sign, but it's actually a negative sign. A negative sign, such as the one in -1, tells us that the number is to the left of 0 on the number line. -1 is red, -1. Now I know this looks like a plus sign, but this is a positive sign, or no sign tells us that a number lies to the right of 0 on the number line. For example, 3 and +3 both mean +3. Now we go here to example set A. It says the tamarack tree, a kind of larch, commonly grows at the edge of the Arctic tundra and survives winter temperatures of 85 degrees below 0 Fahrenheit. Represent this temperature with the sign number in degrees Fahrenheit. Now let's go back up here before we write our answer. Let's take this number line. Okay, now with this number line, it kind of looks like a thermometer, but we have to rotate this so it would look somewhat like a thermometer. Now if you look here at how this number line goes, we know on a thermometer, when you go up on the thermometer it's positive, when you go down it's negative. So when we say 0 below, we're talking about all values lower than 0 or below 0, which are negative. So let's rotate this back. Okay, now we go down here. It told us that we have temperatures of 85 degrees below 0. So we know it's going to be a negative 85 degrees Fahrenheit. Now we go here to number 2. It says the world's deepest bat colony spends each winter in a New York zinc mine at a depth of 3,805 feet. Represent this position with a sign number. Now whenever we talk about depth is talking about how deep something is. So if it's at a depth of 3,805 feet, that means that it's going down, which is also negative. So they are at a position of a negative 3,805 feet. Okay, now we scroll down here. Now it says graph and sign numbers, section B. During this semester we have covered whole numbers, natural numbers. Now in your course pack it says decimals and fractions. We haven't covered decimals and fractions. That's why I scratched this out. Which all can be written as negative numbers. However, some sign numbers are called integers, which we discussed earlier. Integers are 0, all the natural numbers, and the opposites of the natural numbers. The integers are, we have these dots, which means they go on forever, and then we have a few numbers listed here like -3, -2, -1, 0, 1, 2, 3, and so on. Now, remember what you all learned before about natural numbers. Natural numbers are all of your counting numbers. So you know our counting numbers are 1, 2, 3, and so on. And you also learned about whole numbers, which would include 0. Now what is said here is that if you look here, aside from 0, integers include the opposite of your natural numbers. So 1 and -1, 2 and -2, 3 and -3, and then if you have 4, it'd be 4 and -4, and so on. Every number has an opposite except for 0, and 0 is also considered to be an integer. So we come down here to example set B. Number 1, it says graph -2 and 2 on the number line. So what we do is we go to where -1 is on the number line and put a point there. So that's our graph of -1. Now we go to +2 and put a point there as well. That is our graph of 2. So we're done graphing on this number line. Now, for number 2, it says graph -5, 3, -3. Now we need to cross out these last two numbers because we haven't covered fractions or decimals yet. So we will graph -5. Then we will graph 3. And we will also graph -3. And that is it for that problem. Now we go here to section C. It says comparing sign numbers. On a number line, smaller numbers always appear to the left of larger numbers. Let's review our inequality symbols. Now, this symbol means less than. So an example, 6 is less than 9. This symbol means greater than. For example, 9 is greater than 6. Now, if you want to remember this, like for instance, if you can't remember which is less than or which is greater than, just remember that this point of this arrowhead always points to the lower number. If you notice, this is pointing to the 6, that's the lower number. This is pointing to the 6, that is the lower number. So that's a way of you remembering which way to position your inequality. Now it says here, insert less than or greater than between each pair of numbers to make a true statement. So we had -3 and 3. We know all positive numbers are greater than negative numbers. So we know that our inequality would point to the -3. So -3 is less than 3. Now also, in addition to positive numbers always being greater than negative numbers, 0 is always greater than negative numbers. So we will have 0 and we have -5 here. Now we know 0 is greater than -5. So this point is supposed to be pointing to the -5. Now we look here at number 3. We have this decimal. What I want you to do in your course pack is to scratch out this 0.5 and scratch out this 0.7. So we're going to look at this as -7 and -12. Now to determine which one is larger, when you have both the same sign, what you would do is this here. You would go in your mind and think, okay, which one of these negative numbers is closer to 0? Whichever one is closer to 0 is the larger number. We know -7 is closer to 0 than 12. So -7 is greater than -12. So your arrow will point to this -12. Okay, now with number 4, we'll cross out number 4 because we haven't covered fractions yet. Now we scroll down here to section D. It says find the absolute value of a number. The absolute value of a number is the number's distance from 0 on the number line. So it says the number 5 is 5 units away from 0. Okay, let's test that. We have 0 here. Now let's go from 0 to 5. So we go 1, 2, 3, 4, 5. I'll put an arrowhead to show that we stop here. So we went 5 units away from 0. So that is correct. So we say the absolute value of 5, now these bars here means absolute value. So the absolute value of 5 is just 5. Now the number -5 is 5 units away from 0. Let's test that. We have 0 and we're going to go to -5. So we go 1, 2, 3, 4, 5 places. So we went 5 places from 0 to the -5. So we say that the absolute value of -5 is also 5. Now one thing I want you to notice here is we did not do opposites here, because if we would have did the opposite, sorry to say, absolute value does not mean opposite. If we were doing opposites, we would say the absolute value of 5 would be -5, but you notice the absolute value of 5 is 5. And the absolute value of -5 is 5. It's just the number's distance from 0. Now we scroll down here to example set D. It says simplify. The absolute value of 6 is 6. The absolute value of -4 is 4. The absolute value of 0 is 0. The absolute value, well, we could cross out 4 and 5 because we haven't did decimals or fractions. Now we come down here to section E, the opposite of a number. Two numbers that are the same distance from 0 on the number line but are on opposite sides are called opposites. We saw above that both 3 and -3 were 3 units away from 0. 3 and -3 are opposites. It says find the opposites. We have 7. The opposite of 7 is -7. The opposite of -3 is +3. You don't have to write the plus sign in front of the 3. The opposite of 0 is just 0. And the opposite of 2 is -2. Now, also one thing you need to know about opposites is if you add them together, they should equal 0. 7 plus -7 is 0. -3 plus 3 is 0. 0 plus 0 is 0. And 2 plus -2 equals 0. And doing opposites, there is a specific rule with negative numbers that will be very valuable later. Opposites. If A is a number, then this means negative or the opposite of -A is A. So watch this. Now first of all, we will do our absolute value here in number 1. So the absolute value of 7 is 7. However, since this negative sign is on the outside, we bring the negative sign down. So we get -7. Now number 2, this is just a parenthesis. So we know inside of a parenthesis, -15 doesn't change. But because this negative is on the outside, that means the opposite of what's inside the parenthesis, which would give us +15. Now we go here to number 3. Again, we add absolute value. We do that first. The absolute value of -2 is 2, and then we will bring down our negative sign because this negative sign is on the outside of the absolute value. Now with number 4, we're dealing with a parenthesis. Parenthesis 12 is just 12, and the opposite of 12 is -12. Now it says find the opposite of each number. The opposite of -7 is just 7. Now number 2 we could just go on and do it even though it has a decimal. The opposite of a -9.6 is a +9.6. The opposite of 0 we know is 0. And even though this is a fraction, we should know the opposite of a +11/15 is a -11/15. Okay, now it says applications of integers. Where do we see integers used in everyday life? Just like that was said earlier, temperature and determining below sea level or determining sea level. So we could write temperature and then also sea level. Okay, now it says example, a deep sea diver is 836 feet below the surface of the ocean. Represent this position using an integer. So we know if it's below the surface of the ocean, that would give us a negative. So it'd be -836 feet because it's treated the same as below sea level. Now we go here to section F. It said reading bar graphs containing signed numbers. Reading signed numbers are important, especially when reading graphs and making determinations about information. It says here, set E, according to the bar graph below. Okay, now we have our graph here, the average surface temperature of planets, and it's in degrees Fahrenheit. It asks us which planet has a higher average temperature than Mercury. Now, the one that has a higher average temperature than Mercury is Venus. And what is it? It's 867 degrees Fahrenheit. Now we go here to B. It said, which planets have a lower average temperature than Earth? I listed those, and what are the temperatures? They're listed here as well.